Welcome back to DEGN Talk. Today we have a very special guest, which I've been trying to get hold of for several weeks, right? Let's welcome Eric from Polyhedra. Eric.
GM, happy to be here. Thanks for having me. Yeah, we've been playing a little bit of phone tag and, conference season is picking back up. So it's good to be back home and have some time to hop on the pod.
Yeah, no, we just finished Hong Kong and Denver, right? You know what? Straight off the bat, what do you think of the market right now? We all know, currently the situation is, but what's your view for the market in like the next couple of months?
Yeah, I'm very optimistic. I think, regardless of the kind of near-term market sentiment, when I've been talking to teams, they're working on some really cool, like innovative ways to use the blockchain. I know you're working with a bunch of AI companies. We're getting into some very cool stuff with ZKML, which I know we'll dive into later in the pod, but it's just exciting. I think we've spent a long time kind of building out this infrastructure and hardening it and testing it and getting it ready. And we finally gotten to a place where we're starting to see some really cool applications come to life. And regardless of kind of what the market looks like today, I am extremely bullish on the future.
Nice. Give us a brief overview of your journey in Web3 thus far.
Sure. So I've been in startups for my entire career. I started off on the Web 2 side, primarily doing marketing, but I do have a little bit of a technical background. So I've gravitated towards companies that are catering to developers. I got personally invested and interested in blockchain in about 2017. And a few years later, I was working at a developer focused startup called People Data Labs. Was selling data to developers to build sales and marketing software or recruiting software on top of our APIs. And I got a message from a recruiter about a head of marketing role at Layer Zero, one of the top interoperability protocols, to kind of build out their marketing function. I took that job and then met the Polyhedra team while I was at Layer Zero. They are one of our, biggest partners. Polyhedra runs a DVN, a decentralized validator network, that utilizes our ZK bridge to verify cross-chain messages. And so when I kind of was looking for a new opportunity, I already knew the Polyhedra team. I was really impressed with the quality of their research and engineering side of the business. And it was a really exciting opportunity to kind of build out the go-to-market function at Polyhedra. So just a combination of a really great team, a really great opportunity, and then professionally, something that I was excited about doing. So it just made the transition really easy.
No, amazing. Polyhedra is very lucky to have you. I'm very lucky to have you on this podcast as well. So, Eric, amazing. Great moves. Now, let's talk about Polyhedra. Tell us about what you guys are working on right now, especially things like verifiable AI, right? Really fast proof generation, all that good stuff.
Yeah, absolutely. So I'll kind of start at the beginning. Back when we were really focused on ZK interoperability, our team wrote the paper, literally titled ZK Bridge, that proposed this idea of utilizing zero knowledge proofs to share data between blockchains. Blockchains are really good at keeping data secure within an individual blockchain, but once you talk about bridging data between blockchains, that kind of trustless mechanism sort of breaks down until you start to utilize something like zero knowledge proofs. One of the problems that or friction points we had to overcome is that nobody wants to wait for their assets to move between chains. And zero knowledge proofs at this time a few years ago, we're still relatively new. It could take quite a while for even large, powerful computers to generate a zero knowledge proof of a transaction inclusion and zero knowledge proof of the consensus of a particular blockchain. And because of that, we had to kind of go back to the drawing board and figure out, how can we improve the proof generation time? And so our team spent a lot of time researching different proof systems, kind of landed on the GKR protocol as the proof system with which we wanted to base ours on, and we started to build out our own proof system. Over the past, a few months ago, we've open sourced that. The proof system is called Expander. It's based on the GKR protocol. It is currently the fastest proof system in the world. I think the latest benchmarks we're doing something like 15,000 Kekek hashes per second. I think the next fastest is somewhere in the range of 2,000 to 3,000. So we're substantially faster from a proof generation standpoint. And what that does is it enables us to generate proofs extremely quickly. And so we can generate a proof of the Ethereum full consensus in under 10 seconds. So now we have this mechanism where we can generate a proof of blockchain consensus faster than the blockchain's actually generating blocks. And so the zero knowledge proof is no longer a bottleneck. And now you can have the security of ZK and utilize that for interoperability without having to sacrifice on the speed. And that's really crucial, because as much as people tell you that their number one priority is security, what you find when you actually talk to them is speed is actually quite important as well. And now that ZK Bridge is pretty mature, it supports 25 plus networks, it's secured over 30 million cross-chain messages. We started to think about what other types of applications can utilize the proof system that we've built in order to power some of the characteristics that ZK brings with it, whether that's privacy or verifiability or scalability. And obviously, there has been an explosion in AI over the past couple years. I use it on a daily basis to help me with my job, and even on the block, in the Web3 space, I think we've started to see, this actually start to have some product market fit. How does AI and the blockchain work well together? And one piece that we kind of think is missing, or that we believe companies building AI solutions should be more concerned about, is the black box nature of AI in its current state. You give it an input, whether it's an LLM or an agent, you ask it to do something for you, and you get an output. And there's very little transparency. You don't have transparency into the data that a model was trained on. Oftentimes, you don't even have a verification that the model you expect an application to use is the model that's actually being used. And we can use some of the solutions that we're building in the ZKML space to add verifiability to AI. And what we hope that does is highlight the need for trust between humans and AI, and add a mechanism with which we can foster that trust.
Yeah, now it seems the team has overcome a lot of technical advancements in this field, because it's not easy to get that, get the speed that we've achieved, right?
Yeah, and I think there are alternatives. Like, this idea of verifiable AI has been presented before. It is something that I think people are thinking about. You hear a lot about it in TEEs, trusted execution environments, are an alternative to ZKML that can be used for verifiable AI. I think that there are a couple issues with TEEs. One is that there still is some trust. You need to trust whoever's manufacturing the chip, or whoever's,
Right. If they get compromised, your
if
stuff
they get
is
compromised, or the supply chain,
automatically
or
compromised.
there's still an attack vector there. Whereas with ZKML, it's completely cryptographic. So, as long as you understand the code that's being run, there is no kind of additional trust assumption. And the second, and the main pitch, I think, for TEEs for a long time was ZK is not fast enough, ZK is too expensive. And because of the advancements that we've done, because of us focusing on improving the speed of ZK and improving or bringing down the cost to generate a zero knowledge proof, that's no longer the case. And so once again, we're kind of, we were building the solution when it may have been slower and it may have been more expensive. But now that we've spent so much time at this low level, bringing down the cost and improving the speed, we're now getting to a point where, again, you can have all of the advantages, all of the trustlessness of ZK without having to sacrifice on the speed and cost front.
Yeah, exactly. There's a lot of real world kind of implications, applying this kind of verifiable stuff, because unfortunately humans can't be trusted.
Yes. I mean, that's one of the reasons like
We
so
just
many people
cannot, we
build
just
in
cannot
blockchain.
trust each other, man. Like that's just humanity, man. Like it's kind of, if you think about it, the reason we're making these technologies is because we can't trust each other. It's kind of a sad thing, but it is what it is, right? Because we live in a big jungle, right? There's various different type of people, so we got to protect ourselves. So able to
And
kind
well,
of
I guess,
do that.
and you can also kind of extrapolate that, right? We kind of believe in blockchain and we believe in building these trustless systems because humans can't be trusted. So why all of a sudden are we building AI that's going to have control over like significant critical decisions at enterprises in our own individual lives? Like you're hearing about um, companies that are or projects that are building agents that you fund with a wallet and then go ask them to go manage it, find the best yield, find the best trading opportunities. All of a sudden we've forgotten kind of that whole point, right? We kind of, you can't even trust yourself, but now we're trusting AI, and that, it just seems silly to me.
It's like it's such a sad thing to say, but it's like a big brain moment where all of our technical advances are based on not trusting each other. Like,
Uh-huh.
if you think about it, like all these really insane kind of technical advances based on me not trusting you, and I want to protect myself. And that's where most of those come in because everyone thinks like, oh, you know what? That's actually a very good idea.
Yeah, not trusting another person, not trusting the banks, not trusting the government, not
Yeah, not
trusting.
trusting banks is how decentralization came into play, right? Because they messed
Exactly.
up in 2008, right? And some guys like, you know what? This has to end. We can't give him everything, right?
And that was right when I was hitting the job market right out of college. Maybe that actually was the my
Oh
first
wow.
my first reason that I kind of got drawn to the blockchain and to Web3 was because I kind of was going into the job market right during this financial
And the
crisis.
only
And
thing you can do is flip burgers at that point in time. Basically, right?
basically.
So your team has developed something called ZK PyTorch, right?
Yes.
For compiling verifiable models, etc. How does this make life easier for people who wants to build and devs? And what kind of interesting applications are you seeing right now?
Yes. I think that any machine learning engineer is probably going to be familiar with PyTorch. It's a commonly used developer tool for kind of building models and training models. And what we have done is we've kind of added this ZKML functionality, this element of verifiability to the a developer pipeline without any change necessary. So developers can go about their usual development process like they would for building any model. And instead of utilizing PyTorch, they can utilize ZK PyTorch, which then compiles the model, does everything similar to it would normally if you were just using PyTorch, but it also creates the circuits and creates this ability to generate a proof every time that a model inference is run, so that you can generate that proof and get verifiability in the most simple form, verifiability that the inference that you're getting came from this model. But you can imagine that there are many other constraints that you may want to add to a particular proof to prove that, the data that the model was trained on was compliant or didn't violate any intellectual property, it doesn't have any intellectual property issues, or that that the data the model was trained on is not biased, or there's a number of ways in which we can kind of think about adding verifiable elements to different types of AI applications.
Nice. You're working on this GPU acceleration for proof generation as well, right? Um, could you share your vision on how this could transform the AI verification landscape? And how does us as normal users or trenches would take advantage of that?
Yeah, so I think again, right, it's all about ZK for so long. It wasn't seen as a real possibility for some of these use cases because proof generation took so long. And we kind of solved that problem with Expander on the interoperability side. Now, on the ZKML side, there have been attempts at utilizing ZK for verifiability within AI. I think previous attempts at creating a proof of an LLM, with let's say billions of parameters, would take something on the order of like days to generate the proof. And more recently, when we generated a proof of the Llama 8 billion parameter model, it took about 2.5 hours. And we are working on GPU acceleration because we are confident that with that, we'll be able to bring that down to sub-minute and eventually sub-second proof generation. So now you're no longer thinking about utilizing verifiability after the fact, maybe to come back and make sure that things went well, or if there's a dispute to figure out what went wrong. But you can actually utilize it in real time. So every AI inference can come with a proof to prove that the inference was executed correctly, that the model you expect it to use was used, that the data that the model was trained on was unbiased and untampered with. And so, we are going to get to a point, thanks to GPU acceleration, where we can have real-time verifiable AI via zero knowledge.
Wow. Yeah, no, we need the speed, right? We need to be private, and then the stuff inside it needs to be trustworthy, because like if you don't trust other humans, you're gonna have to trust something, right? So that's something that we are working hard to kind of prove, right, with what we have here.
Yeah, and I think that there are a lot of examples or a lot of different areas we're exploring where privacy and verifiability need to happen. So you can think of what I like to call machine learning as a service. So there are these companies that are building these models that may want to license them out. Let's say that you've developed a model that can beat the S&P by 10% every year. You have probably a very lucrative product that you could license to probably every, institutional investor out there. At the same time, you can't actually reveal the model. You can't reveal the model weights. You can't reveal the data that it was trained on, because then you lose your moat. You don't have, that's like your secret sauce. At the same time, the people that are licensing this model from you are going to need some sort of verification that the outputs that you're giving them are coming from this same model that had the historical performance that you're showing them.
You can be trusted.
And so exactly, again, it comes down to trust. So in this kind of machine learning as a service type of business exchange, you're going to need ZKML. And then I think the other one is open source models, where the inputs from an individual user need to remain private. Let's say that, you want to use a model to, help you get your finances in order, but you don't want to share your financial information with a particular whoever's running this model, or with this model creator. Well, that's another area where you can use ZKML to kind of obfuscate the inputs, but still give you verifiable outputs. So there's kind of two here. There's times when the model needs to remain private and you need to get verifiability of the model execution, and times when maybe the model is public, but your inputs need to remain private. In both these instances, ZK can play a very big role in facilitating this, maintenance of privacy.
Last question for you, Eric. So looking ahead, what's on the roadmap for Polyhedra in the coming months? And what trends are you excited about the convergence of this AI and kind of Web3 narrative?
Yeah,
any alphas? If you've got any alphas,
I'll definitely share some alpha for the DEGN podcast. So we're continuing. I mean, most of what we're doing right now is going to be centered around the ZKML and verifiable AI pieces of our business, and we have our blockchain, our layer 1 blockchain, EXP chain. The reason it's called EXP chain is because it is kind of a lot of the functionality and a lot of the support is centered around Expander, our proof system. So there's going to be a lot of just native blockchain functionality like single slot finality, expanded proof of stake, native ZK bridge integration that's going to be very relevant for anyone building any application on the blockchain. But there is also going to be some functionality that's going to be very specific to AI builders. And with that is going to become, support for these proofs that are generated by these ZKML models built using ZK PyTorch. Those proofs are going to be very cheap and very fast to verify on EXP chain. And so EXP chain is on testnet right now. We're continuing to iterate on testnet and hope to have mainnet live by the end of Q2. So very excited about that. We also have a number of kind of Web 2 AI partnerships that are going to give access to a lot of like AI API, AI developer tools for builders building on EXP chain. So really excited to start to go public with a lot of these partnerships we've been working on behind the scenes. And then one project in particular, kind of an application of our ZK Tech is going to be this verifiable AI agent marketplace. We have some really big partners lined up for that. It's just, the explosion of interest in AI agents. It's been very hard to miss. Again, there are some of these teams where we've gone to them and we've showed them this ZKML technology, and they have been really excited about it. They've been excited about this idea of, because like you said, there has been skepticism in some of these AI agents. Is this really AI in some instances? There's not a lot of transparency. A lot of it is very opaque and black box in nature. And so we're excited to kind of build out this marketplace where developers building AI applications and AI agents can add this element of verifiability to them, and then have this kind of place where users can go to discover and with the expectation that these agents and applications are verifiable via Polyhedra's ZKML tech.
Nice. Well, I think that's it, folks. Eric, thank you very much for your time. And I hope to see you again on DEGN Talk. We'll make a series out of this. And for the viewers, I'll link a bunch of different links, which Eric will provide to me into the tweet, where people can go and kind of have a look at more information regarding Polyhedra and its new tech and new features, etc.
Awesome. Well, really appreciate you having me on, and thanks to everyone who's listening. It was great to be here. Great conversation.
Thank you. And I'll see you guys next time.